All right, so the directions on this one, it says state the possible rational zeros for each function, then find all the zeros. All the rational zeros, those are the p's over q's. All right, so all the factors of p being the first term is going to be 1, 3, 9, and 27. All right, and those are all plus or minus. All the factors of q are going to be plus or minus 1, plus or minus 3. And remember, all the p's over q's is what you're looking for. So that's all of these things over 1. So that's plus or minus 1, plus or minus 3, plus or minus 9, and 27. And then now we have to put them all over 3. So that's plus or minus 1/3, plus or minus 3/3, plus or minus 9/3, plus or minus 27 over 3. And so since this equals 9 and we already have it, it's gone. This is gone, and this is gone, because we don't need any overlap. So all we have here is our Tetris block of possible rational zeros. Now, I'm going to use these, let's see, 1, 2, 3, 4, 5. There are 10 possibilities because it's all plus or minus. I have 10 choices to choose and put them into synthetic division. Let's see, my coefficients are 3, -8, -12, and 27. What number am I hoping to get as a remainder? 0. And so does anyone have a number that definitely worked? Taylor? 3. That one worked, so we pull down a 3 here, so we've got 9, 1, 3, -9, and -27. And so now, since that worked, we can say x equals 3. And now, this used to be x to the third, it is now x squared, so 3x squared. This was x squared, it is now x, and then minus 9 equals 0. A lot of people are wondering, well, what do I do from here? You still need to find all the zeros, whether they're rational, irrational, or imaginary. If something can't be factored, and we have a coefficient out here and an odd number, it's best just to jump straight to the quadratic formula. So a equals 3, b equals 1, and c equals -9. So negative b plus or minus the square root of b squared is 1 minus 4ac all over 2a. Whoops. Okay, so now let's go and clean this up a little bit. Sean, I think I led you astray with this problem. -4 times -9 is positive 36. Times 3 should be positive 108. So it shouldn't have been 107. It should have been 109. And I don't believe square root of 109 can be simplified, so that just moves straight into here. So -1 plus or minus rad 109 over 6. And those are your 3 answers for this problem. Any questions on this? Anything? Couple of layers on that one. You have to use the quadratic formula, and you have to use P over Q synthetic division. All right, number 21. Where's my packet? All right. State if the given functions are inverses. Holy guacamole. This is some ugly stuff here. G of n is equal to the 5th root of n plus 2 plus 2. F of n is equal to 2 parentheses n minus 3 to the 5th power. Okay. So the way to figure out if two functions are inverses would be if g of f of n equals n, and then f of g of n equals n. Now I have a funny feeling that this is not going to work out, but let's see what happens. If I take g of f of n and I compose them, I am taking this whole quantity and I'm going to plug it into there. Okay, so that equals the 5th root of 2 n minus 3 to the 5th power plus 2. Oops, and then plus 2 on the outside. Okay, let me pause real quick so I can figure out what this is. So after we do all of this, we get some really big 5th power polynomial, and then we have to multiply it all by 2. So what I get is the 5th root of 2n to the fifth minus 30n to the fourth plus 180n plus blah, 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 all that stuff. I know that if I take the fifth root of that and add 2, there's no way I'm going to get n. So therefore the answer is no. Yeah? Yeah. That's what we just did. Yeah, all that work for nothing. By the way, that what you see on the board right there, you guys are going to learn that in about 2 weeks, 2 or 3 weeks. It's easy. It's a Pascal's triangle to figure out what things to large powers are. Simple. Okay, so that was 1. Did we just do 21? 25. Okay, 25 is something that we should definitely explore, and it's neat. G of x equals x minus 2 over 3. And then f of x is equal to negative 7x plus 4. So again, I'm going to see if f of g of x equals x, and if g of f of x equals x. Now, if one of these conditions isn't met, problem's done. The answer is no. So let's see what happens if I find, let's do g of f of x, because I think that's easier. So I'm going to take this, and I'm going to plug it into here. So g of f of x is equal to negative 7x plus 4 minus 2 over 3. I'm going to combine those two, so I get plus 2. So I get negative 7x plus 2 over 3. Is there any way I can simplify that to make it an x? No. So since that's no, what's the answer? Answer is just straight up no. They are not inverses of each other. All right. No, it has to equal x. 28. Okay, find the inverse of each function. So 28 here, g of n is equal to 2n minus 1. The first thing I'm going to do is I'm going to replace this g of n with a y, and I'm going to say y equals 2n minus 1. Now, in order to determine what the inverse is, I am going to switch n and y, so I get n equals 2y minus 1, and now I just try to get y by itself. So I'm going to add 1 to both sides. So I get n plus 1 equals 2y, and now I divide by 2. So I get y equals n plus 1 over 2. And there's your inverse. Okay. Okay, number 30. Number 30. Okay, same type of problem here. Good. So g of n equals the cube root of 2, I'm sorry, not 2n, n minus 2. Minus 1. All right, so again, just like the last problem, no should not be part of that problem. I'm going to go ahead and switch this for y. Y equals cube root of n minus 2 minus 1. I'm going to flop n and y, so I'm going to get n equals cube root of y minus 2 minus 1. I'm going to add 1 to both sides, so I get n plus 1 equals the cube root of y minus 2. And now I'm going to go ahead and cube both sides. The only little trick to this problem is that you have to cube everything as a group. So it should be n plus 1 cubed equals y minus 2. Now, keep things simple. Don't worry about cubing this whole thing. It's not n cubed plus 1. You have to FOIL it out 3 times or use Pascal's triangle. So it would be 1, 3, 3, 1 on your pattern there. Just add 2 to both sides and keep it simple. Y equals parentheses n plus 1 cubed plus 2. And that's as far as you need to go for that problem. Yeah?
How come at the beginning you switched it, but then you switched the y's and the n?
Because you're switching for y, which is generally your output function, and then you solve for it because you want your output to equal your function. Yeah, you're just trying to get y by itself because that's what you're outputting every single time. So that's the whole point of the problem. 31. Who asked for 31? Do we really need to do that one since it's the same type of problem? No. And then 32 is the same type of problem, so I don't think we need to do that one either. 54. Complex fractions. We need to find a common denominator on the bottom. So do not think very hard. What is the common denominator of this problem? Don't think. Taylor?
2 times 2u minus 3.
Yeah, 2 times 2u minus 3. So we need to multiply each side by what's missing. So the left is missing a 2u minus 3. And then this is missing a 2. So let's go ahead and mess this up a little bit. If I distribute in, I get 2u squared minus 3u minus 2u squared all over 2 times 2u minus 3. And don't forget, there's a 4u minus 6 over u above that. So it looks like these two are going to cancel out. That's kind of a cool thing. I'm going to also factor the top. I can factor a 2 out, so I get a 2u minus 3 over u times, now I'm going to go ahead and multiply by the reciprocal of this. This is, oh, that's not doing what I thought it would do, but that's okay. 2u minus 3 over negative 3u. That's too bad. Okay, so now what I was hoping that these would cancel each other out, but I guess they don't. So from here, multiply smart. 2 times 2 is 4. 2u minus 3 times 2u minus 3 is 2u minus 3 squared over negative 3u squared. Whose question was this? Caden, are you feeling okay about that now?
Yeah.
A little better? Yeah.
So if you were not getting more work, like this.
Much more. It wasn't? What is it? Oh, you know what? Because they actually foiled it out. Yeah, they actually foiled out the problem.
Wait, would we have to FOIL it out on this test?
Nope. 55. Okay. So same type of problem. What's my common denominator on the bottom? Nate. X times x minus 2. So this needs an x. This needs an x minus 2. So on the bottom, you're going to get 25x minus 50 minus 25x all over x times x minus 2. And then you get an x over x minus 2 up top. 25x's are going to go away, so you end up with negative 50 over this thing. I'm going to go and parachute this thing up to the top and multiply it. So I get x times x minus 2 over negative 50. Anyone know what's going to happen next? Chris? X minus 2's are going to go away, so you end up with x squared over negative 50. Nate? X times x. Julia, how are you feeling? What can I do to help alleviate that? Besides, take the final for you. Okay. That was 55. 56 is a similar problem, so we can pass that over. Let's go to 63. Okay. solving an equation. By the way, before we take off today, we're going to do a couple of inequalities because those are going to be, I mean, if I have anything to do with writing the final, it's going to be heavy in inequalities. This is an equation, which means that after we find a common denominator, what can we do? Cross out the denominator. So what is the common denominator here? Let's see here. Wally. 6n squared. So what's missing from any of these? Yeah, an n's missing from the middle and the right term. So once those are gone, we can say that 1 equals n squared minus 2n plus n squared plus 3n. So, oh, I get some nasty stuff down there, but we can get rid of that. So, I'm going to combine these. I get 2n squared. I combine these, so I get plus n equals 1. So I'm going to subtract 1 from both sides because I'm dealing with a quadratic equation. So this is 2n squared plus n minus 1 equals 0. I feel that they can be factored. I'm not sure. I will say 2n and n. I'm going to say a 1 and a 1. They have to add to here, so I'm going to say plus 1 minus 1. So n equals 1/2, n equals negative 1. Let me just check our domain, though, and make sure that we're all okay. We are okay. So n equals 1/2 and negative 1, we're good. All right, so I'm going to let you guys work for another 10 minutes, and then we're going to get started with the inequalities section because I want you to keep practicing those. Let's start with something easy. What do you do with this problem here? Anyone remember? I just kind of gave you the answer. Chris?
You find the, I don't know what it's called.
Critical numbers.
Yeah.
Critical numbers. So, remember there are critical numbers up top, critical numbers on bottom. What's the critical number up top? What's the critical number on bottom? Max? 2 and negative 3. Now, please remember, your critical number is not 2 over negative 3. It's 2 up top, negative 3 on bottom. Nate?
What number is this?
This is number 34 on the inequalities worksheet.
Oh, and is that what is that?
An x plus 3. Okay, so please remember that your problems from this inequalities worksheet, which was given to you last week, will be your question bank for the final. Okay, thank you for letting me know that. Okay, so now we take our critical numbers and we plug them into our sign chart. So negative 3 and positive 2, I'm going to partition it downwards. And now x minus 2 times x plus 3. A number way smaller than negative 3 is negative 5 trillion. That's going to produce a negative number here and a negative number here. In between negative 3 and 2, let's choose 0. 0 is going to give me negative, positive. Beyond 2, let's choose 2 trillion, positive, positive. So that's going to give me a positive, negative, and a positive. Which intervals am I interested in? Which intervals am I interested in? Lauren, which intervals am I interested in? Say again? The positive ones, because I'm looking for the ones that are greater than 0. So now, how do I write this in interval notation? Teacher Joseph, how do I write this in interval notation? Negative infinity, comma, negative 3, union, 2, comma. So, if you paying attention? Positive infinity. Thank you, Teacher Joseph. And now, Teacher Joseph, can you tell us what types of brackets are we going to have? Soft, soft, because we cannot include negative 3, and then hard bracket, soft bracket. All right, thank you very much. Any questions about this problem before we move on? Raise your hands if this is like somewhat doable, like you're like, okay, I remember how to do this kind of. Okay, good, because I would say that a lot of this final is going to revolve around this stuff. Okay, how about we do something like 46? 2x plus 1 over x minus 1 is less than or equal to 3. How do I deal with that 3? Gabby?
You subtract negative. Oh, you subtract 3 over.
Subtract 3 over. So what I get is 2x plus 1 over x minus 1 minus 3 is less than or equal to 0. Now, from here, the biggest mistake that I saw in the quiz is people jumped straight for critical numbers right after this. That is not correct. You need to find a common denominator and combine all your like terms before finding your critical numbers. So, what is our common denominator here? Julia, can you tell us what our common denominator is? And can you tell the world since you're live? It is x minus 1. Good. And then an x minus 1 on bottom. So, what we get, I'm going to move this over, is I get 2x plus 1 over x minus 1 minus 3x plus 3 is less than or equal to 0. Sorry, that should be more centered, but that's okay. We will fix that in a second. Now I'll combine like terms, so I get negative x plus 4 over x minus 1 is less than or equal to 0. And now, actually no, not yet, I should probably factor out a negative 1. So let's move this thing back here. Negative 1 times x minus 4 over x minus 1 is less than or equal to 0. Let me clean some of this junk up here. What are the critical numbers top to bottom? What are the critical numbers here? Kenna, what do you think?
4.
4 and 1. Good. So now, pump this thing into the sign chart. So I've got a 1 and I've got a 4. Now I pump in all of my functions. I have 3 of them. I have a negative 1, I have an x minus 4, and I have an x minus 1. Negative 1's easy because it's negative regardless of where you go. Now I need a number smaller than 1. So let's go 0. That's going to be negative, negative. In between 1 and 4, 2. So that's negative, negative. I'm sorry, negative, positive. And then 5 trillion is going to be positive, positive. So my final intervals are negative, positive, negative. Now, which intervals am I interested in? Devin, the negative ones. I'm less than 0. So I need to find a way to write this in interval notation. This is a 1, by the way, not a long partition mark. What are my intervals here? How about, let's see here. Dustin, you got the intervals? Uh-huh. Union 4, comma, positive infinity. And let's see here. What are our brackets going to look like? We cannot include 1, so that's going to be soft, soft. Hey, it's similar to the last problem. Any questions on this? Please, please don't forget to find a common denominator before you find critical numbers. So,
You know how we tracked down negative 1? How come you don't use that as your critical number?
because there is no way that a critical number in here, there's no way a critical number can exist in here because it's just negative 1. There's no x attached to it or anything. Right? So, another way of looking at it, so take all 3 of these individually and set them equal to 0. So, x minus 4 equals 0, x minus 1 equals 0, negative 1 equals 0. Well, this is where x equals 4 comes from, right? This is where x equals 1 comes from. How often does negative 1 equal 0? All right, let's do one that is a little more tricky, like 56. No, 53. I feel that I will like 53 more. So 3x over x minus 1 is greater than or equal to x over x plus 4. So now I'm going to go ahead and subtract x over x plus 4 from both sides. So I get 3x over x minus 1 minus x over x plus 4 is greater than or equal to 0. Now from here, it's critical numbers, right? 0, 0, 1, 4, negative 4, right? No, what do I got to do? Common denominator. Liam, what do I have to do before I find critical numbers? Find a common denominator. Good. This one needs an x plus 4. This one needs an x minus 1. So my whole thing is over x plus 4 times x minus 1. I'm going to distribute this in. I get 3x squared plus 12x minus x squared plus x greater than or equal to 0. Let's go ahead and combine some stuff here. I got 2x squared plus 13x. That's kind of cool. Oops. Okay, so from here, I'm going to go ahead and back this thing over. I'm going to factor out an x. So I get x times 2x plus 13 over x plus 4 times x minus 1 is greater than or equal to 0. Now, in order to find critical numbers, what you do is you set each individual piece equal to 0. So, Soph, here comes your question again. I'm going to set every piece here equal to 0. So x equals 0, 2x plus 13 equals 0, x plus 4 equals 0, x minus 1 equals 0. So my critical numbers up top are going to be 0, comma, negative 13 over 2. My critical numbers on bottom are going to be negative 4 and 1. Raise your hands if I have moved too fast for you. Let's pause for a second here. Okay, now that we have our critical numbers here, 0, negative 13 over 2, which is 6.5. All right. Let's pump those in. So I've got, oh man, what I don't have is enough space. Okay, so let me clean some of this garbage up here. Getting kind of all over the place. Okay, so here, negative 6.5, negative 4, 0, and 1. So let's partition this downward. All right. So my functions are x, 2x plus 13, x plus 4, and x minus 1. Negative a trillion is going to give me negative, 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 negative. In between negative 6.5 and negative 4, anyone have a number between 6.5 and 4 on the negative side? Yeah, see? Negative 5 sounds good. That's going to be negative. Negative 5 times 2 is negative 10 plus 13 is positive. And then negative 5 into here, and then negative 5 into here. Between negative 4 and 0, so let's go negative 2. That's negative. Negative 2 times 2 is negative 4 plus 13 is positive. Negative 2 here is positive and negative. Between 0 and 1, 1/2, so let's say positive, positive. Let's see here, positive. And 1/2 minus 1 is negative. And then 5 trillion is going to be positive for all 4. So my final intervals are going to be positive, negative, positive, negative, positive. We are looking for where this is greater than 0. So which intervals are we looking for? Chief, where are you at, buddy? Which intervals are we looking for if this is greater than 0? Positive ones, right? So boom, boom, and boom. So now we have to write this in interval notation. Let me get rid of this equation here, or this inequality. All right, so positive ones is going to be from, who knows what the interval notation of this thing is? What is it? Julia, what do you got for us? Actually, it's a different type of 6.5. It's, there you go. Uh-huh. Sounds good. Now we just got to figure out what kind of brackets we have because there is the chance of inclusion. We cannot include the infinities. We know that. We cannot include negative 4. We cannot include 1. And everything else gets a hard bracket. Okay. There you go.